Here we want to integrate the function f of x, which is equal to the square root of x. So if we're integrating f of x dx, then our function f of x is the square root of x, and we're still differentiating with respect to x, and I can rewrite the square root as x raised to the 1/2. And this is a power, so I can just use the power rule. So the power rule for integration would be x to the 1/2 plus 1 divided by 1/2 plus 1 plus, on the very end here, the constant of integration. So 1/2 plus 1 is like saying 1/2 plus 2 over 2. So that gives me x raised to the 3 over 2, and 1/2 plus 1 is 3 over 2 in the denominator, plus this constant of integration. And 1 divided by 3 over 2 is the same as 2/3. So I have 2/3 x to the 3 over 2 plus the constant of integration, c. So this is basically the antiderivative, capital F of x. And if I want to check the solution, then I can differentiate the antiderivative. So I would be differentiating 2/3 x to the 3 over 2 plus c. And what I'm looking for is that I end up with what I started with, which was f of x equals the square root of x. So if using the power rule for differentiation, I have 2/3 times the derivative x to the 3 over 2, so I have to bring down the 3 over 2. X 3 over 2 minus 1 gives me 1/2, plus the derivative of a constant, which is 0. And here I have 2/3 times 3 over 2, which cancels out, leaves me with 1. And so what I'm left with is x to the 1/2, which is exactly the same as the square root of x.